this tutorial, we are going to solve a question from your tutorial sheet 4, which is on chemical equilibrium. Okay, so it's saying, write the equilibrium expression K and Kp for each of the following gas phase reactions. Okay, so we've been given this gas phase reaction, then we have to write the K and Kp value for the reaction. So if you've been given the general reaction, let's say A, okay, it's having a specific coefficient. Okay, so let me put a 2 there. Okay, so let's say we're having A, there's a 2 there. This is gas state plus B. These are the reactants that you're having. Okay, they say this is in also in gas state, it's giving us. Then we are having, let's say 3C in gas state plus D. Okay, in gas state. Okay, so what you will notice that if you are to write the K expression for this one, what you're going to be getting are the concentration of the products that you're having divided by the concentration of the reactants that you're having. That is the equilibrium expression that you're going to get there. So the K, these are the equilibrium expression. So for the K, you're going to get, so you get the concentration of the products, and you can see here the products that you're having. You have C and D, isn't it? So in this case, C, you get the concentration of C. Now this C has a coefficient 3 there, isn't it? So we're going to power it to 3, okay? And then we multiply it with the coefficient of the concentration of D with its coefficient, which is 1. So we can't just put 1 there, it's okay, even without putting, right? Okay, divided by, we do the same with the concentration of the reactant. So we get the concentration of our reactants, so we get the concentration of A, we power it, multiplied by the concentration of B. Also, we're having a coefficient of 1 there, so we are not going to put anything. This is the K expression for this equation there, the general equation. So for the Kp, we are going to be getting the pressure, isn't it? So for the Kp, this expression, so we get the pressure for the products divided by the pressures that you're having for the reactant. Okay, so for the products we're having C, so we get the pressure for C. Okay, then we're going to power it to 3, isn't it? Then we multiply by the pressure for D. Okay, so we're not going to power it to anything because the coefficient of D is 1, isn't it? Okay, divided by, we get the coefficient of, we get the pressure for A as well. Okay, so we power it with a coefficient which is 2, isn't it? Multiplied by the pressure for B as well, power it to the coefficient which is 1, isn't it? So this is the Kp expression. Okay, so that's what we have in there. So we can come up with the Kp and the K value for this the K expressions for these reactions that we've been given there. Okay, so let's start with the first one. So let's start with the K expression. So we're having N2 plus O2 is giving us 2NO, and we can see all of them are in gas state, isn't it? So in that case, the products that you're having is NO there, okay? And D, there's a coefficient of 2. So what you're going to get is the concentration of NO, okay? Then we're going to power it to 2 divided by the reactants that you're having. So we have the concentration of N2. The coefficient is 1, so we are not going to power it with anything. Multiplied by the concentration of oxygen. Also, the coefficient is 1, so we are not going to power it to anything. So that's the K expression. Okay, for the Kp, we're getting the pressure, isn't it? So we get the pressure for NO. Okay, so we also power it to 2, isn't it? Because the coefficient is 2. Okay, divided by also the pressure for N2. So we're not going to power it to anything because the coefficient is 1. Also, the pressure for O2, we're not going to power it because also the coefficient is 1 there. So this is the Kp expression, and this is the K expression for the first reaction there. Okay, let's go to the second one, which is B. Okay, for B, so for B we are saying the K expression, that case going to be the concentration of the products that you're having, which is NO2 there. So we have NO2, we power it to its coefficient, which is 2 there, okay, divided by the reactants that you're having, it's N2O4, okay. Also, we're going to power it to its coefficient, which is 1, so we're not going to do anything. So that's the K expression for this reaction there, okay. For the Kp, we're just using pressure, isn't it? So we get the pressure for NO2, we power it to 2 to its coefficient, then divided by the pressure of N2O, okay, O4, okay. So we're going to power it to nothing because the coefficient is 1 there. So that's for reaction B, okay. Let's do the same to reaction C, okay. Reaction C, we are having the K expression to be equal to, so the concentration of the products that we're having, which is Si, okay, Cl4, okay, no coefficient, so we're going to power it to nothing, multiplied by the concentration of hydrogen gas there, okay, and we notice that the coefficient is 2, so we're going to power it to 2 there, right, divided by the reactants, the concentration of the reactant, which is SiH4, okay, the coefficient is 1, so we're not going to do anything there, we're not going to power it to anything, multiplied by the concentration of Cl2, okay, then the coefficient is 2, so we're going to power this to 2 like that. That's a K expression, isn't it? For Kp, we're just using the pressure, isn't it? So we get the pressure for CiCl4, okay, multiplied by the pressure for hydrogen gas. So now this one we are going to square it, isn't it? Because the coefficient is 2, divided by the reactants that we are having. So we are having SiH4, okay, the pressure for that one. We are not going to power it to anything because the coefficient is 1, isn't it? Then multiplied by the pressure for Cl2, okay? Then the coefficient is 2 there, so we're going to power it to 2. That's what we are having, okay? So we can do the last one there, okay? So for the last one, we are having the K expression to be equal to, so we get the concentration of the products that we are having, okay? So we're having the concentration of PCl3, okay? So we're going to power it to 2, okay? Multiplied by the concentration of Br2, we're going to power it to 3, isn't it? Okay, because the coefficient is this one here, divided by the concentration of the reactants. So the reactants we're having PBr3, okay, the coefficient is 2 there, so we're going to power it to 2 times the concentration of Cl2, and then the coefficient is 3, so we're going to power it to 3. Okay, so that's the K expression. For the Kp, just going to be getting the pressure. Okay, so we get the pressure for PCl3. Okay, we're going to power it to 2, multiplied by the pressure of Br2. We're going to power it to 3, isn't it? Because the coefficient is 3 there, divided by the pressure for PBr3. Okay, so this one, we're going to power it to 2 because the coefficient is 2, multiplied by the pressure for Cl2, as well, we're going to power it to 3 because the coefficient is 3. So that's how you come up with the K and the Kp expression for the gas phases. So here we are considering only gas phases here. So we're having only gas phases that we're having. Those are the K expression and the Kp expression that we are going to get in that case. Okay, so this is this question got it from sheet 4 on chemical equilibrium. So let me just show you the entire sheet. Okay. So this is the tutorial sheet on chemical equilibrium. You can see all these questions here. Okay. So now, if you want to access a full video solution on this tutorial sheet, you can access them on our website. So you just search discretelearninginstitute.com. If you are using an Android phone, you can download our app on Play Store. Then you should be able to check the courses that are available. So if you subscribe for chemistry, you go in the folder for chemistry, you go in general chemistry. Then once you go in general chemistry, it will take you to other folders. So you notice that you have a folder written tutorial sheet and assessment. So you go in that folder written tutorial sheet and assessment. Once you go in that folder, notice that you are going to have you have to pick the university of your choice. Okay, so once you pick the university of your choice, then you notice that you have 2 semesters. So you pick the second semester. Once you pick the second semester, you're going to notice that there are other intakes there. So you pick the intake of your choice. Okay, so which is the uh, January 2026 intake. Then you should be able to see these tutorial sheets that are available. So for this one, you go in that folder written tutorial sheet for chemical equilibrium. Then you should be able to get all the full video solution for this tutorial sheet. Thank you so much.